Do you know what factor of safety is? Do you know how to apply it for slope stability analysis? In this video, I'm going to explain the concept of it, and then you will see what you can do in the industry or when you do research and you try to estimate the factor of safety for a different slope. Let's just look at this example when we have, it's kind of physics mechanism of what can happen. So let's assume that we have this part that can move down, and that will be the potential landslide mass, and it's sitting on this slope which is very stable, and typically it will be bedrock. So what is going to happen is because of the weight of this block that we can see as a potential landslide mass. So because of the weight and the slope inclination here, theta, there will be shear stresses acting downward, trying to drive it down. So this part is constantly under shear stress. So shear stress here, I'm going to write it here, right? So at some point it's going to be stable. So this is stable because there is friction. There is a friction between this stable part, the slope, and this block on top of that. So typically we have friction between these two surfaces, and that friction will keep this block stable. So it's not going to move at some point, right? So this is the concept of factor of safety. So what we can do is we would like to know what is going to be the strength, that friction, and we call it available strength. And we also need to measure what the strength is actually required to keep this block stable. So we are going to have the ratio. So factor of safety is the ratio between available strength to the required strength, right? So if we have available strength, we have lots of strength available, which is much greater than the strength is required to keep it stable. In this case, factor of safety will be more than 1, and we assume that slope is stable. There will be cases when we have this driving shear force, which is greater than the strength available here to keep this block stable. So in this case, factor of safety, the ratio between available strength and required strength will be less than 1, and this slope will be considered unstable. Another way to look at factor of safety, you can see it in the literature. Factor of safety is equal strength of either soil or rock divided by the shear stress which is acting as a driving force because of the gravity and because of the angle of the slope incline, right? So this is what can do, this is just another way to look at the factor of safety. So if the strength that is available to keep this block stable on the slope is greater than the shear stresses, which originated from the weight of the block and the slope inclination, in this case, again, factor of safety will be more than 1 stable. And if it's less than 1, it's going to be unstable. So how do I estimate the shear strength? It's very common to use Mohr-Coulomb failure criteria, where we have here normal stress and we have this value of cohesion. So in this case, if we rewrite it, that factor of safety will be equal to cohesion plus normal stress times tangent of friction angle. And here we're going to put shear stress acting on this block. So you will see that in some formulas, some methods of slope stability analysis, especially limit equilibrium methods, you will see that on top there is always components like cohesion and friction angle. So they all come from the strengths of, for example, in this case, if we deal with the soil, it will be a strength of the soil. If we deal with the rock mass, so it's going to be a strength of the rock, right? And let's look at the special, what we call critical conditions. So what is actually going to happen when factor of safety is equal 1? is it stable or unstable, right? So I ask my students this question, and they usually come up with the correct answer. So when we have a factor of safety equal to 1, so this means that the slope is stable. So it's still stable, but it's marginally stable, which means that it's just right on the verge of collapsing. So if there is a little bit of change in the shear strength of the, let's say, soil, it will decrease. In this case, it will become unstable, and it can result in the landslide. Um, Okay, that's it for the factor of safety. Watch my other videos where I explain how to estimate slope stability analysis and how we use factor of safety there. Bye.